Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Debugging software can be a pain or an exciting adventure. If you have unit tests, your process may be easier when user testing or quality assurance finds a bug in your code. In this episode, we'll look at what constitutes a software bug, how to find them, and some tips for dealing with them once they are located. But before we get started, Will, what's been bugging you this week?
I've been involved in some entity framework shenanigans. It's like most ORMs, they don't do very well at bulk operations, and they sometimes do funny things when you have a large list of items and you say, I want anything that's got an ID in this list, because it converts that to a SQL end statement, and that's got a limit. And there's user interface issues that cause this to happen too. And so we were like, oh, we'll just do a bulk thing, right? So we found this bulk extension that looked like it was open source, looked like it was free. Well, it turns out hidden on the website, it's like, well, actually, it kind of goes away every month. And you have to re-download the new version and redeploy. Otherwise, it starts throwing exceptions when you call those methods. We found that out on the first. That was lovely. We've reworked it and gotten away from that. But management was like, hey, go take a look and see what it would take to do this, kind of what they're doing. And I've been into like all the interceptors and hooks and all the stuff that you can do with the DB context, basically responding to events and changing the SQL going through there and looking at what that library was capable of and looking at how you'd have to implement it. Like, it's code that I just backed away from. That's not something I will do very often. Right. But that was just like, no, and it fits in with the discussion we're going to have in this podcast, because I was pretty sure I was like, yeah, I could do this. Right. But if something goes wrong, I'm not confident that I can debug it. And if something goes wrong in production, I'm completely unconfident that I'll be able to ever figure it out. And so I had to kind of like bail out of it. So yeah, it kind of fits with the topic of the week. So how about you?
Well, I knew there was a big Windows update because when I turned it on today, my laptop fan was going nonstop, full speed, and did not take a breath. So yeah, it was that time for the big old Windows update. If I could only roll my eyes with audio, that would be nice. I've got the Mac Mini sitting right here. I started setting it up before the semester started, and I have just been swamped. My professor told me that it was going to be, kind of work at your own pace, not a lot of work. It'll be pretty easy. Do not trust your advisor when he's trying to fill a class. All I'm going to say. That's all I got to say about that. I don't have it on here in the outline, but I did get my midterm back and I got an A on it. So I'm quite happy about that. So that's a good thing. I spent like quite a bit of time studying for that, so I'm very happy about that A. That is a good thing. So I think I told you guys I had an audition coming up. I had my audition for the worship team last week. I'm not going to go into too many details here in the podcast. You can check out the aftercast because I might go into more details there with the other musicians. I don't really want to bore Will with it, but I will say playing with other people is very different, very, very different than playing solo or playing with a track. Like, I've got recordings of the worship team playing the songs that I was playing for my audition, and it's still very different playing with a track versus playing with real people. So that was an adventure, one I hope to get to do more of. So I find out tomorrow afternoon. We set up a time, I think 1:30 tomorrow. I get the call about how well I did on my audition. So I'm looking forward to it, because even if I didn't make it this time around, I know the process. Like, she's going to call and tell me what I can do to improve. So that's really exciting because I'm like, hey, now I know what I need to do to improve. I've like gotten over the initial, oh my goodness, I'm going in there and doing this. And so next time I'll come in having made those improvements and be like, I'm not going to be as nervous. I'm going to get some experience playing with other people. Going to have that going into it. So I'm kind of excited about that. I got some friends who have offered to get together and do some jam sessions with me. So that'll be a lot of fun too. Speaking of being artistic and stuff, I am getting back into painting and writing. I've had a few ideas for both. And actually, last night when I was writing this outline, I took a break for a little bit and went and did some painting. That was kind of nice. I'm not finished with it. It's been quite a while since I've done any painting, so it's not that great. But I've got an idea. I just want to follow it through, see how it goes. I might come back to it and redo this painting some other time. But right now, it doesn't look bad. It's just not my best work ever. It doesn't look exactly the way I had imagined it, but I'm not done with it. So we'll see if I get to make those changes or if it how it turns out. So that's kind of fun. Saving money is hard, especially when you're constantly being bugged.
Lucas Casades is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
Yeah, and just like us here at Complete Developer Podcast, his focus is on helping you not only establish a plan, but take action on that plan so that you can live your best life.
Yeah, and investing in financial planning services really comes down to whether you can make more money by having done that than you invested. And Level Up can help you do this because there is a compounding impact of making better financial decisions that will pay for itself.
And the nice thing is that Level Up has a unique pricing model that will help you no matter where you are on your journey. So if you're just starting out as a junior developer or you are mid-level, like mid to senior, you're in the prime of your career, or even if you're starting to think about retirement, they have a plan just for you.
Yeah, and speaking of journeys, when you want to go on a journey, you want to go in the right direction, right? And what Lucas does is he makes that happen. He's a fiduciary for his clients, which means he's not going to sell you something that sends you the wrong way. Instead, he guides you towards a better direction.
Yeah. So you guys can catch his podcast, Techie Personal Finance Boot Camp, where he covers financial topics that you likely face and interviews other IT professionals who share how they navigated through their careers. And you can also learn a lot more at his website, levelupfinancialplanning.com.
Debugging is an essential part of software development. No matter how great of a developer you are or how meticulously you code, you will run into times where your code doesn't do what it is expected to do. And those times are 24 hours a day. Some days. Sometimes this is an error in the actual code. Other times it may be an unexpected interaction that your code has with the rest of the system.
Yeah. When this happens, you have a bug. Wikipedia defines a software bug as an error in the design or implementation, coding, of a program or application. Debugging is the process of locating the source of the bug and then fixing the underlying problem causing the bug. While it seems straightforward, bugs can be rather tricky as they may not present themselves in the area of code where the problem actually exists. A lot of times, you'll notice a problem in one area of the application, but the actual code causing the problem is in a totally different area or even different layer of the application.
Or in another microservice for that matter.
So true. Oh, so true.
Man. I've had it where it like sends out something that's expecting, a webhook address to go with it. And it's going to call the webhook when it's done. And if you send the wrong address, it never comes back. And so it's like, oh, the data's corrupt at this end. It's like, yeah, it was corrupted like 6 months ago. And you just now found it. Like it's a real thing. So while it's important to understand what a bug is, it's just as important to understand what a bug is not. Network errors, server outages, and slow connection are not software bugs. You may want to update your code to better handle these situations, but they're not bugs. It's important to know what a bug actually is so that you're not wasting your time trying to fix something that is not in your control. Now, I did have a question on that. Do you still consider it a bug if your reaction to those things breaks the system?
Possibly, possibly, but the network error server, those things are not the bug.
Right.
It's your reaction that is the bug.
Yeah. Like I've seen I worked with a guy who, if the network connection went down once, his app would never connect to the database again.
We're going to talk about understanding the difference between symptoms and root causes a little later in the episode. So, speaking of that, in the episode, we're going to start off talking about the basics of debugging, looking at things that you need to know and consider before you start debugging, including determining if you are actually dealing with a bug. Then we'll go over the process of tracking down a bug, like how to do that. And finally, we'll discuss some tips for resolving the bug once you found it.
In the aftercast, we're going to go over 9 different techniques for debugging. And you can check this out on Patreon. It's $5 a month. It gets you access to all of our aftercasts.
Little plug there for the aftercasts. All right, guys. First off, before you begin, you must be able to replicate the bug consistently. This is key. Like before you go any further, you have to be able to replicate the bug. It is not possible to fix a bug you can't replicate.
Or to prove that you fixed it.
Yeah, that's the thing. You'll never know if you actually fixed it or if it was even a real problem to begin with, and not just like some quirk of the way someone had a setting in their browser, if it's a web app, for example.
Yeah, or a cosmic ray.
Yeah.
At some level, there's a lot of weird stuff that can happen. In order to be able to track and understand what's causing an issue, that issue needs to happen on a consistent basis. Inputting the same values must create the same results, even if they're wrong, for it to be a consistently replicable bug.
Yeah, it needs to be idempotent.
Yeah, well, it's not really idempotent. It's almost like the mathematical definition of a function. You put the same inputs in, you get the same input out.
Yeah, yeah.
With no side effects. Like it needs to be predictable. It needs to be subject to the scientific method. If it's not, then you can't determine whether it's a bug. You may still do something that makes it happen less or possibly even not happen at all, but you can't prove, in fact, you can't prove that it made it happen less. You may have just changed the interval. Ask me how I know that one.
That's the thing with this is if it can't be replicated, it's not a bug. That doesn't mean it's not a problem either, because you may have some issues that, they can't be replicated, but it's still a problem. The term consistently inconsistent refers to something that happens with enough regularity to be noticed, but it's not consistent. It doesn't happen every time. And typically, when you see something that is consistently inconsistent, it will be related to a race condition.
Yeah, and we need to do a show on those too, because it's hard to understand stuff getting out of sequence because our brains don't really work that way most of the time.
Yeah, the best way that I can think to describe a race condition is you have 3 different things that change the same variable, and they all start running toward the finish line. And depending on which one hits in which order, that's going to be what the variable is.
Yeah, it's kind of like the 3-body problem in physics. It adds an element of unpredictability based on, well, of course, the 3-body problem isn't based on timing ish. I mean, that gets really deep into physics before you get too far along there. But yeah, anyway, many times users and even less experienced QA will blame the app or your code for issues with their own machine or their connection. This typically stems from a lack of understanding how computers function, especially things like cache. Slow internet connection is not a bug unless you're ops, but your QA person may ding you on it. Mine won't, because I've got pretty solid ones, but in the past I've had some that were, you really have to have a lot of patience when you're explaining this stuff, because yes, it's not your fault, but they're going to probably confront you with it anyway.
Yeah. I had a QA, and I think I've told the story before, but he got so irate because I told him, like, I sent him an email. I was like, hey, just finished, or I think it was a Slack message. I was like, just finished and pushed up this new feature to the app, the UI and Angular UI. I was like, you're good to go. And he came to my cubicle just all upset. He's like, it's not there, like just freaking out. And I'm like, did you do a hard refresh? And he went off on how the users aren't going to know to do a hard refresh.
Well, and that's true, but that's also irrelevant because they don't have to.
Yeah, this is someone who had a degree. And I'm like, okay. At that point, I'm like, I don't know what to do. I don't know how to explain this to you because it's just like, yeah, they're not going to have to do that.
Yeah, you can't think him out of a position he didn't think himself into. So you just have to sit there and take it. So speaking of sitting there and taking things, you need to check the documentation to make sure that this is an actual bug and not an unexpected feature. I've seen plenty of those where you just don't understand how the system works. That's the bane of your existence once you get a complicated enough app. Not everybody on the team is going to understand every piece, and bugs are going to get reported that are actually legitimate features that somebody wanted. Somebody coded that on purpose.
Yeah. If you're using an outside service or you didn't write the code yourself, you really do need to check the documentation to make sure that your users haven't found a feature that they just had never known about before.
Yeah, and even if you did write the code,
well, there is that too.
I'm not going to say that your memory is going to be perfect or that somebody else may have touched it since you did last too, right? Like you just don't know. Especially when you get feature flags and things like that in the mix, it gets weird pretty quick. When you're the one building the application and QA throws something back to you, you also need to check things like acceptance criteria. If you have them, if you don't, you need to start making them to make sure it's doing what it is supposed to be doing. Because like they can't test and prove that it passed if they don't know what they're passing.
Yeah, that's the thing. I remember I got pulled onto a team who had been consistently failing sprints for several months. This was years ago. And the first thing I noticed, well, other than the fact that their stand-ups were 45 minutes to an hour long because they'd get into like two people would get into a back and forth. And I'm like, this is not relevant to the rest of the group. We could all be working. You guys could have a private conversation about this. There was that. But the big thing I noticed was they would accept stories and start working on them before they had acceptance criteria. Or if they did, the acceptance criteria would be so vague, the developers would build something and QA would go, well, that's not what it's supposed to do. And they were both right based on the acceptance criteria. And there were two things I did. I shortened their meetings. And I wasn't even the Scrum Master. I just was like, all right, no, we're like, I was an API developer who got pulled on to help out. And I'm like, nope, we're not doing this. Everybody say your thing. If you guys want to have a conversation, you can talk about it afterward. That's where I got the nickname Thor for dropping the hammer on side conversations. They like, someone, like we start the meeting, someone says hello, BJ's like, that's not relevant.
That's right. Good morning. Is it? That's not relevant either.
No, I wasn't that bad, but I was like, no, hey guys, you can have that conversation, just not right now. This is not the time for that. And what's funny is, other than one or two people, everyone on the team was appreciative of.
There's usually one or two, and those one or two people will be the ones that create bugs, partially because they're not following a process to not have them. And the idea here is to be able to understand what a bug is and what it is not based on the documentation of the system, not just based on your feelings. Your feelings don't matter. Get over them. A bug occurs when the application is not functioning as it is supposed to function. This doesn't mean how a particular user expects it to function, unless that user is the product owner, in which case their rule is law.
Yeah, I had to throw that in there. I typed up that.
Well, one of my POs listens to the podcast, so
yeah. No, I typed up that, and then it hit me. I was like, well, unless that user is the product owner, in which case,
well, and it's kind of flexible for them a lot of times too, though.
I will say this: a good product owner, and I've seen them do this. I literally saw this in a meeting last week where our product owner didn't specify how he wanted something, and so we presented it. He's like, I'm going to pass it because it literally meets the acceptance criteria. but I'm going to tell you, I'm going to write a story to go make these changes. So just be ready for that.
I've seen mine do that too.
I appreciate that because we built what you asked for. If you didn't ask for the right thing, that's not on us. That's on you. And it
needs to show in your metrics.
Yeah.
Not mine.
And they take responsibility for it.
Yep.
And I appreciate that.
Yeah, I do too. It helps a lot. And especially when you can just look and you go, hey, I've got an adult that I'm dealing with, not a temperamental child.
Yeah. Like if I make a mistake, I'm going to take ownership of it. Like yesterday, I got distracted and I was setting up the release process and I thought that I had set up the automation and I hadn't. And so like I started it, stepped away, got distracted doing some research for the next story coming up. And it was 2 or 3 hours later that I was like, oh, QA can't test because that never actually got released. Let me go fix it. And I was like, I am so sorry. This is what happened. And our QA was just like, thanks for being honest about that.
And I'll tell people during a meeting, I'll be like, I'm kind of dumb. So if you think I screwed up, like, let me know.
Yeah.
Like, it's really okay because it's only offensive if I don't know.
Yeah. Yeah.
But I'm kind of aware of my shortcomings. And it's sort of like knowing what a bug is.
Yeah, that's true. Speaking of bugs, sometimes they're not actual problems with the application or the code, but problems understanding how something is supposed to function. And like we said, this could be due to misinterpretation or vague acceptance criteria.
This happened to me today. We had a field in an export that was called is credit. And I thought that it was a credit card payment was what I thought that was. And so we were porting an export from one system to another so that it was the same data. And it actually meant, no, it's like a bank credit. Like the money's going back. And so I misinterpreted it, put the wrong field in there. It's a misunderstanding. It's like it did what I was intending it to do, but it was not correct. And you'll see that sort of thing at a large scale, all the way up to UX type stuff.
The next thing you have to check before you can even start looking for your bug is to make sure there are no service outages. Legitimately, your code may be flawless with no problems or issues. I suppose as much bad buggy code as I have seen, there has to somewhere exist. I'm doing the what's that movie? The Bruce Willis where he's like superhero but not a superhero. It's an M. Night that guy movie. I'm terrible at pronouncing his last. Anyway,
along.
Yeah. But anyway, it's the idea that hey, if the one extreme exists, then the other extreme has to exist too, right? There is flawless code out there somewhere. But if you have flawless code and there is a service outage, nothing you can do via your code will get the application working again. There is no point in looking through code to figure out why you aren't getting results from an API if the server hosting the API is down.
You really have to start your inquiries about why a function or application is not working properly by looking to see that everything is up and running. Like if you can't get there from here, or if you can't get there consistently from here, like there's intermittent failures. Intermittent is one of those words that's kind of like shamalamalong or whatever. It's hard to pronounce sometimes. Check that the servers have not been down or that someone is not deploying a new release. That one's really annoying, by the way, if you don't have good communication on your team, because somebody will push something out and all your stuff breaks and you're getting pinged about it and you don't know what's going on. And oh yeah, we just decided to release in the middle of the day.
Or if you're in there testing in dev to make sure that what you've pushed up, that you announced to everyone, hey, I'm pushing something to dev. Now, I know you guys have separate dev environments for each, and that is
they're allocated.
We'll eventually get there, but like I have worked places where you had one dev environment, and if someone was like on one of the teams, it was just me on the API and then a UI developer, and so if he was making sure something was working on the UI, if I didn't say, hey, I'm about to push something up to dev, I could totally mess him up. And he wouldn't know unless he like started going through the debugging process that, oh, it's not anything that I did wrong. So
yeah, I was in one environment where we had, it's not really a test environment so much as it was the environment. And so they were QAing it. They were doing customer demos on it. It's just like it was really bad from a separation of concerns thing. And so we had somebody doing load testing and they put like 90 million rows in this one table. And they were demoing it to customers and we were doing work on it too, and we're changing the schema, and stuff is breaking just like all day long. And they did finally get a second database, I think, after that one. But they put it on the same server, so the load testing still killed it all. But at least it wasn't my fault then.
It is likely that your code or an area of the code you're debugging is calling an external API or service. So you don't want to just check your own servers, but also check that the external services are not down. Especially if like they have like a dev or test environment and you're calling that, because that's more likely to go down than something else. So like check that those services are down before you start really diving into figuring out what's going on.
Yeah, I feel like a lot of these service providers will put their dev and test environments on like an E machine from the late 90s. Some of those things you're just like, like what baud rate's your modem, bro? It just really, they're dog crap when they're up. And so, yeah, they fall over all the time, and you can't necessarily make an assumption that they're going to be up, which is actually good for you from a coding perspective, right? Because you plan for that because you have to catch it.
And you should not say stuff like that when I'm taking a drink. I almost spewed my non-alcoholic beer all over the place.
For what? The crack about the E-machine?
Yeah. I was like,
tell me I'm wrong.
No, you're right. That's why it's funny. Is you were right.
I mean, you're just like, you could upgrade to a Raspberry Pi if you want.
Yeah, I know, right?
They're cheap. Get 2 of them. Then you got a QA environment.
Oh, yeah. I mean, if you do find that your servers or ones from a service where you're using are down, now's a good time to look at how you're handling that in your code, like we talked about earlier in the episode.
Because that's the only thing you're going to look at.
Yep.
You should also rerun, check, and rewrite your unit tests. Once you verify that you have an actual bug on your hands, you run unit tests to see if you can find it. In other words, hey, did this slip through and the unit tests should have caught it, or our build pipeline didn't check to make sure unit tests passed? Somebody flipped that off and it got out. Not that that's ever happened anywhere that I've worked. Actually, it's only happened once or twice because most places thought unit tests were a waste of time, but it should have been a problem more places than not. Yeah. If the unit test didn't pass, then something has changed in the code that's causing the bug, and you can find out where fairly quickly. I mean, that's the point of unit tests, honestly. More than likely, though, those tests are going to pass.
Yeah, because it's a lot of times it's not some flaw with the code. It's unexpected behavior of the code.
Or date times.
Well, yeah, there's that. Yeah. Or it could be that your unit tests aren't testing what you need to be testing because you just didn't think of it at the time. That I have seen a lot of.
I mean, one thing that I always red flag is if I see a datetime.now in a unit test, because that's indeterminate behavior, right? I mean, as far as like the next time this is run, I don't know what the date and time actually is. So therefore the test is not a repeatable pattern.
Now, if you don't have unit tests, now may be a good time to start that conversation. Not all code is going to be testable, so some of it may have to be rewritten. That means now is not the time to start implementing unit tests. You got to figure out what's going on with your code first. However, you can point out how bugs are caught much faster with unit tests in place.
Yeah, once you get to the point of knowing where the bug originates in your code, you can start actually writing a unit test for that area that tests against the replicable bug that you're facing. And note that it has to be replicable, right? Mm-hmm. And that's why I brought up the date time issue, is because this will get you here. Because you'll go, oh, this test should pass, at the end of the month. Well, what does it do on the first? This allows you to easily test potential fixes without having to go through the whole path to get to that part of the code again, right? So you can write a little quick test, creates a condition, sets it up, runs it. If it blows up, then yes, okay, we got the bug. When we fix it, now it's going to pass. 6 months from now, when something presents itself and we run again, that test will run. It should pass again. We know we didn't break it again.
Now, after you have found the fix for your bug, you want to run your unit tests again, all of them, because there is not much worse than spending hours tracking and fixing a bug only for that fix to cause another bug. and you don't know it until it gets out to production.
Well, and it's the odds of
'Cause
being
you're,
able to, huh?
I was like, because you're in a hurry to
Yeah.
get this fixed, and you push it out, and it causes something else.
Look at it this way: you're changing how the system responds to state.
Mhm.
So you're changing the inputs to everything downstream, potentially.
Mhm.
So there's no way that you can get by without running all your other unit tests, or you can't prove that you didn't cause things to get worse.
Next, you need to know the difference between symptoms and causes. And I mentioned this in the introduction to the episode that we were going to talk about it. So here we are. This is the center of the episode, the middle point, and it's kind of like the most important one. I put this here because this is sort of the linchpin of this episode, and that is that you need to understand the difference between symptoms and the cause. Because a lot of times the way a bug presents is not what's actually going on. This concept is where I got the idea to write this episode. This happened to me literally yesterday. No, Friday. My bad. It happened Friday, where I had been working on, we've got a new project that we're starting. Well, a new app within the same workspace in Angular. And I was working on the build and release process for it in the cloud. And so I got the build set up. But since we're moving to the cloud, I've been taking notes and writing up wikis for us. So I was like, oh, hey, there are two ways to do this. I did it the long way to write up the wiki. Now let me go and just sort of like follow the process to do the copy and paste the YAML files and stuff and write that up. I accidentally pointed to the wrong YAML file while I was in there, and somehow it saved, because I was doing this just to kind of like, get some practice, or just to see what the process was to write down, like click here, click there kind of thing. So when I got the release finished and run, I go and I'm getting login errors. That's weird. We haven't put auth in there. Like, it literally just says the app is working. Like, it's very, very basic. And
It's
so
basic Angular.
yeah. And so I reach out to our architect who's been like helping us, like, because we're the first ones, our team is the first ones on the cloud. And I was like, hey, is there some setup where it's like expecting the authorization stuff to be there we don't know about yet? And do I need to go in and put that in? And he's like, no. And through the conversation, we realized if you watched when you like refreshed, it popped up the name of the other app in the browser tab right before it took you to the auth stuff. And I was like, I see what I did there. But the symptom was an authorization error. So that was the first place I looked, because it's the obvious. But that was not the cause. The cause was the wrong build pipeline. That said, it is very easy to confuse the symptoms of a bug with the actual cause. They're what you see. So usually the first thing that comes to mind involves fixing the obvious. And a lot of times that works. Unfortunately, symptoms are not always the real issue going on. And sometimes the symptoms actually hide the issue from what's going on.
Yeah, a symptom just answers the question of what is happening, whereas looking for causation answers why is it happening. Treating symptoms does not actually fix the issue causing the problem. It just delays solving the problem.
Treating the symptoms of a bug a lot of times involves sort of a hacky solution to get around the problem. Now, definitely want to say this is not always a bad thing. For example, you got an app that's down and you have to get that up and running. So you can fix the symptoms, get it up and running while you diagnose the real issue. And so treating the symptoms there can buy you kind of some valuable debugging time where your application is not down. It's like
medicine.
Yeah, it's like taking an antipyretic when you have a fever. The Tylenol, when you've got, like, let's just say a virus or a cold or something, and it's not actually treating the root problem. It's not killing the bug in you. It's just keeping you from overheating. It's treating that symptom so that your body can deal with it without causing further distress to you.
Something that does happen more often than it should is that one bug may be masking another bug. So once you resolve that bug, then the other one is able to be noticed. This is really rough when you've accepted the first bug for a while and you're just kind of getting around to fixing it. And then you find that, oh, hey, the system was reacting to this in some manner that was letting us get away with this other stupid thing we did over here. And now that I've fixed this, not so much. So, like, I've seen this where there was a bug where something was invalidating the cache when it shouldn't, right? Like, caching is a great example of basically where to get any kind of bug you want. And something was invalidating cache when it shouldn't. Well, this gets fixed. Well, then you find out that, hey, there's all these other pages that are caching stuff that they're not supposed to cache, and it's coming up with the wrong cache key. So, like, somebody's seeing other people's stuff that was cached badly. That wasn't at my current job. That was at a previous employer. But I mean, it happens. And generally speaking, if you see one bug, you should always assume there's another one behind it and take steps accordingly.
And this is why you want to run your unit tests, not only to make sure that your fix doesn't break something else, but to make sure there's not another bug that was being masked by it. Or like if it's hitting the bug at .NET at the controller level and never getting down to the service, or if you're using a repository pattern, the repository layer, then you don't know if there's a bug down there because the bug above it is blocking the process. So yeah, that's why you want to run your unit tests after you fix it.
And instrumentation and QA and like actually treat it like you're a professional. Don't hack this crap because you get busted by it really, really quick.
The only reason to ever hack this kind of stuff is to buy yourself time to do it the right way. It's like, let's get it up and running so that we can focus on finding the real issue and the root cause here. So speaking of finding the real issue and the root cause, we're going to start diving into how to do that. First off, start out by finding the layer of your application where the problem is occurring. Location, location, location. The key to debugging is to know where the bug is actually originating. And so to locate a bug, you want to start broad, the biggest way you can, and then narrow your search down as you eliminate possibilities. Eliminating an entire layer of an application will significantly improve your debug time.
Yeah, and your standard CRUD application, your create, read, update, delete, is going to typically be a 3-tier architecture, at least these days. So you got a UI, you got an API, and you got a database. In fact, most web applications fall into this category to some degree or other, with the possibility of like a service layer or external calls to outside services and APIs. The 3-layer model gives a good reference point, and it's easy to explain how you would eliminate a layer. So you can go, hey, this one's not it because this error looks like it comes from somewhere else.
We're going to use that model for the rest of this point just because it's easy to talk about. It's an easy construct most of us understand. You've got your UI, your API, and your database. So when we talk about eliminating a layer, what we mean is that you're going, hey, I know it's not in the UI. So to do this, you want to start at one end or the other. Usually I suggest when I'm working with junior developers and training, I say, where are you more comfortable? Are you more comfortable on the UI or are you more comfortable in the database? And wherever they're more comfortable, I say start there. So that's going to be the easiest place to start, especially if you find the bug, that the bug is there. That's going to be even better. So start there, one end or the other, and mock up what a call to the next layer would return. So for example, if you're using the UI and calling the API, this might mean mocking up the JSON object that's returned by the API instead of actually making the API call. So where you would normally call the API, you just instead return this JSON object that similar to what the API would return. And so if the UI works without connecting to the API, then you can rule out the UI as the area where the bug is happening.
And similarly, you can go from the other end, right? You go from the database and work your way up. I've done it from the middle before too, because it's an easy place to set a breakpoint and you get like some of your instrumentation's better there. I don't necessarily recommend that for juniors, but a lot of times when you're like, hey, this feels like it's probably right in here, and you get a sense of that as you get more experienced.
Yeah, we're going to talk about that sixth sense in a little bit too. That's like I have that in here towards the end.
Yeah, if all the layers work individually, then you start checking connections between those layers, though. Browser dev tools, good grief, I'm in those all day, every day, to look at network calls specifically to go, hey, is this thing actually returning what I think it's returning? Because stuff gets weird, right? Like you have serialization issues, you're using JavaScript or something built on it for the front end, and so you get all kinds of weird type coercion and stuff like that going on too. And so this is a safe place to start looking at those network calls without some of the stuff in the middle that can really obscure the issue. By the way, this is a great way to find a secondary bug that's actually masking the primary bug that you just discovered.
Yeah, that's true. Have you ever had an issue where someone had gone in and changed the API and they typoed a parameter? And so you're like, I don't understand. Why is it not working? It's like nothing has changed. And then you go and you look at the call. The way I found it was the call coming, like the get. I noticed
The idea here is that you follow the path the code is taking when the bug is occurring. Once you found the layer where the bug exists, you follow the path that is causing the issue all the way to the end or to the next layer. Looking for individual lines of code yet, you're still trying to narrow things down because it may be that, yeah, this is a bug, but stuff shouldn't be getting here this way.
Yeah. And so once you know the layer, and going back to our model here of UI, API, and database, once you say we know it's in the API because what's going and coming from the database is right. When we disconnect the API, the UI works just fine. So we know it's in the API. So this is where you go, all right, let's track a call. Let's track the path that the code takes when we're getting this error. Because remember, this is a replicable bug. So it's every time it makes this particular call with this particular data, we're getting an issue. So we can mock that up. Postman is a great tool for APIs. I use that all the time when I'm working on APIs.
Same here.
You want to start off by looking at it goes back to what we said. It's all going to be broad to narrow. So we've just narrowed it down from the whole thing to the particular layer. Now we're in the layer where we want to narrow it down from the larger organization. So like once you got to know how the code is organized. For example, in .NET, you might start by figuring out which project is causing the problem within the API, or in Angular, which module or component is the issue. Other languages have different constructs for organizing their code. So what you want to do is you want to start with the broadest construct and narrow that down. That's going to be the easiest way for you to do it because you'll start going, all right, well, I know for a fact it's not in this area, so we're not going to look here. We're going to look in these others and slowly narrow it down to where it is.
Yeah, and you do it. It's slow but efficient, right?
Mm-hmm.
Like if you think about some of the discussions we've had on here about search algorithms, you're kind of doing that.
That's kind of where I got the idea. That's how my brain works too. So that's just like, this is literally, I wrote this based on like when I was writing this, I'm like, all right, how do I debug? What is my thought process? And I just wrote it down.
And trimming it down to smaller and smaller sections eventually lets you locate the actual problem or problem areas.
Yeah.
Once you have a general idea of where the bug is located, you start to narrow your search. You want to go broad to narrow, so you start with the widest net and then narrow down from class to method to line of code. One thing that'll bite you here is if you don't start wide enough, you'll completely miss it.
Yeah. That's why we had an entire point just talking about finding the layer. And now we're talking, all right, we understand the concept of broad to narrow. Now we're going, all right, we know the layer. What's the next broadest thing within the layer? And then the next broadest thing. And we go down. A good way to narrow your search from the general region is to add breakpoints at the entry and exit of each class or method called along the path. This way you can see what's being passed in and returning from each method and compare that to what it should be. And that'll help you go, oh, this is the right thing was passed in, but that method's supposed to do 2 + 2 and it's returning quadratic formula. Someone got a little zealous there.
Yeah, I was going to say, all right, man. Yeah, once you found the method that causes a problem, then you start looking for obvious issues. Because a lot of times these things will jump out at you once you've been looking a little while. You'll just go there and go, oh, there's a problem. And you want to get to that point as quick as you can, because if it's a problem where you're having to do this, it's a problem. So go ahead and fix it. Once you found the area where the bug is happening, you scan through the code sort of quickly. Look for things like code smells, look for things, like variable reuse, those kind of deals that jump out at you, code quality issues.
Mm-hmm. You want to beforehand read up, and I'm saying this as prep for debugging, not when you have a bug, but before you ever have to debug, read up on code smells or common ones to know what to look for when you're giving that quick initial glance. This is definitely going to help you narrow down the issue, especially if it's like a larger method that is a code smell in and of itself. But if it is a very large method, if you can glance at it and go, hey, there's a switch statement and that's a code smell. That doesn't mean it's bad, but there's a lot of potential for things to go wrong there. So let me start there.
Yeah. Or you may see something too, where certain members of your team create code that has certain code smells, and you'll get used to seeing those after a while, and you'll be able to debug their stuff, and you'll spot things that they wouldn't, because you know how they screw up, or you know how you screw up, which is the other one that tends to be the one I get to do a lot of.
I think we have an episode on code smells.
We do. It was a very popular one for a while there.
Yeah. So check that out if you haven't already listened to it. A couple of common things that I've seen: hard-coded values or data that got used for testing in a method and should have been removed gets out into the wild. These things shouldn't get that far, but they can slip by. And this is just one of the more obvious things that I've seen when going through and just giving a cursory glance at the code.
Yeah, another issue that may not be super obvious, but you might see it, is if you're making a call that's pointing to the wrong place. This might not get caught in the network tab of your debugger, especially if it's calling the wrong environment, or if it's an issue with the API calling the wrong database or the wrong service. Like, so you're calling the QA database when you're expecting to be calling production.
Yeah,
those kind of things. It's worth looking into config as well, and paying attention to fully qualified URLs, not partials, if you can.
I've seen that where QA was like, all my data's gone. They're like freaking out. And the person who had updated the UI had it pointing to the dev API.
Yeah. Well, I mean, when QA tells you that all their data's gone, it's like, you found a bug. Great job.
Yeah.
You're
being successful.
Yeah.
So guys, finally, and this is the last point because it is very important. Forget what it should do and focus on what it actually does. Far too many developers get stuck on, well, it should be doing this. This is what I wrote it to do, so this is what it does. And completely focus on what they expect the code to do instead of looking at what it's actually doing. They get it in their head that it should work a certain way and just can't even conceive of a world where that is not the case. I've seen this a lot with mid-level developers myself.
Yeah, like juniors will know that they can make a mistake. Seniors are well aware that they probably have mistakes waiting to blow up on them. But you get that little bit of confidence when you get to the mid-level and you think, okay, I'm better than a junior dev and I don't make stupid mistakes anymore. And you kind of have to make enough stupid mistakes to realize, hey, this is a permanent facet of my life. And so somebody that hasn't gotten there yet will get fixated on what something is supposed to do versus what it does. And a lot of times code doesn't work the way you expect. I mean, a lot of stuff can happen that will cause a loop to exit early, or a function to return the wrong value, or you just didn't understand what something is really doing. Like, this is a great way to, deep load your whole database. It's very easy to get into the situation. So don't focus on what it actually does. It's really easy to do this. So don't focus on what it is supposed to do. Like actually look and see what is really happening and then deal with that, because that's the actual reality.
Yeah, that's true. When you're debugging, the best approach is to go in with no expectations whatsoever and just go, hey, whatever happens, happens. That's not possible for a lot of people. So if you're not able to go in with no expectations, go in with the expectation that nothing will work as expected. What's going to happen is this will open you up to accept the reality of what is happening rather than living in the fantasy world of what should be happening. And this applies to a lot of areas.
Yeah, it's really easy to fill in the gaps with what you think should be there. And you want to get rid of that tendency because it wastes time. When you focus on what the code is doing, even if that doesn't make sense, it's going to help you, track down why it's not behaving as expected. It's a matter of accepting reality and then making a plan to change reality. That's the whole point of debugging. It's not, hey, I'm going to change reality with a fantasy, because you're going to screw reality up when you do that. There's whole political movements that do that. It doesn't work.
Yeah. I was listening to a podcast today talking about your imagination and how fantasy is like a twisted imagination. Like imagination you can make become real. Fantasy is, oh well, I want this to be real, so I'm just going to focus on that and not on the reality or making it a reality. So guys, the process for tracking a bug is broken down here in this episode. Though for most people, once they've done it a few times, it starts to become kind of automatic. You get that sixth sense we were talking about. You'll begin to notice patterns in the bugs you fix so that you can know that it's in a certain place in the code and where you want to start looking. These patterns aren't perfect, but they often provide a good starting point. Use the information here to develop that sense of where you need to look. But also remember that patterns aren't perfect and that you may need to go back. If you go there and it's not where you expected it to be, you may need to go back and follow the broad to narrow path to determine what part of the code is causing the actual problem. Now, don't forget to check out the Aftercast, where we're going to talk about 9 specific techniques for debugging. You can find that on Patreon. For just $5 a month, you get access to all of our Aftercasts. That pretty much wraps it up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I'm going to say something that cranky old developers said to me back in the days when I was learning Visual Basic. So like in the before times. And their premise was that debuggers are a crutch. And I never really understood that until I started kind of managing people and having to deal with production applications in an environment that I could not control, specifically because of Sarbanes-Oxley. I couldn't get in there and poke. Mm-hmm. And we have lots of good tips here for, what you do when you are trying to troubleshoot something. But one thing you don't want to do is default to, hey, I'm going to fix this by debugging in the future. So you want to have things like instrumentation, logging, those kind of issues. You want to be using enterprise design patterns. You want to have the assumption that if it gets to the point where I have to debug, that's fine, but I don't want that to be my first line of defense, right? You don't fix a head cold with surgery.
In the Aftercast, we're actually going to talk about debugging when the app crashes and you can't run a debugger.
Yeah. Or I'll tell you one that was a ton of fun for me was actually writing code that hooked into Visual Studio and trying to debug that. That was not a happy place. But sometimes you can't. And your assumption should be that you are not going to be able to actually debug this code necessarily with the inputs that cause the problem. Right? So like it's great if you can and you can step through, but put stuff in place so that one, you can figure out what the problem actually is from production without trying to hook to the production database from your developer machine. Mm-hmm. In other words, this kind of goes with a theme that I've been developing lately, which is to assume chaos and understand that it's the default. And so debugging is how you triage chaos, but what you really ought to be doing, hopefully, is trying to be in a position where the debugging is less necessary. So just kind of keep that in mind. That's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/CompleteDeveloperPodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.CompleteDeveloperNetwork.com. Thanks for listening. See you next time.